Denest may come from the fact that some people think of the radical symbol as a nest. We want to remove the radicand from its nest. Who knows where these unfortunate instructions came from? A lot of people just use simplify. Now, the approach I'm going to use right here is just the fact that squaring and square rooting are inverse functions. Now, you know, technically this would be absolute value here. That is, the square root of an object squared is that object's absolute value. But since everything's positive here, we don't really have to worry about the absolute value bars. So let's move along right here and do the natural thing, which is to do this equality here. Now, all this is fairly routine. You just expand out the left-hand side, and this is the standard a squared plus 2ab plus b squared form you get when you square a binomial. And we equate it to the radicand of the original problem, okay? Now, again, these assignments are fairly natural to try. I'm not saying they're obvious, really, but so you see a rational number right here, so it makes sense to let the so-called a squared plus b squared terms, the rational part, be equal to the rational part, so to speak, is how I'm treating the problem, okay? Now, so if we equate 2ab and 3 root 47, that certainly implies that one assignment would be b is equal to 3 halves. Now we could do a is equal to 3 halves also. It's a symmetrical problem, okay? But what does this imply? This would certainly imply that a is equal to the square root of 47, right? And y'all, I'm not saying this is etched in stone because maybe there's other assignments I don't know. These are the natural assignments. These are the natural assignments, and we're trying them. If we could test them, if they don't work, they don't work. Okay? So anyway, what does that lead to right up here? If b is equal to 3 halves and a is equal to the square root of 47, we have to check. If we're making these assignments, we have to check to see if this statement right here is true. Okay? So we would get, just from right here, we would get 3 halves squared. Whoops, I lost my marker again. Okay. We would get 3 halves quantity squared. And y'all, really the driving force behind this, if you just take a look at the original problem and you see that there's a 3 right here, you know that half of that would be consistent with this 2ab portion. Okay, it's just half. When you complete the square and things like that, you're taking half of this, except you would be taking half of 3 the way this works out. Okay, and when you square it out, the 3 halves, you get 3 halves plus 3 halves in the expansion, which is 3, which is what you're interested in, right? Now, okay, so we're questioning this is okay. So we have the square root of 47 right here, or no, a is equal to, which one did I do here? A is equal to, well, it doesn't make any difference what order we do it in. We'll just do square root of 47 right here. Squared, it's symmetrical, so in addition it's commutative, so we don't care. All right. So what is that equal to, folks? This is equal to 9 over 4 plus 47, right? And of course, this would be equal to 9 plus, we need 4 times 47. 4 times 47 is 188. Okay, which is equal to, and this is over 4, sorry. And y'all, that's equal to 197. Sorry, I got it kind of crammed in here. 197 over 4. Okay, so that proves that we can take a equal to square root of 47 and b equal to 3 halves. Okay, or the other way around, just because of the symmetry, right? So we can write this as, let me just come up here and write it. We can write this as 3 halves plus the square root of 47. That's our answer, folks. Again, you can almost see it in your head. If you, not quite, you have to be able to do the common denominator stuff, I guess. But this is our solution, and we've denested in the sense that we removed this outer radical. Okay? All right, y'all. Thank you for viewing.